Hello guys, in this video we are going to discuss the solution of the problem maximum sums problem. So let us look at the problem statement. A number n can be broken into three parts, n by 2, n by 3 and n by 4. Each number obtained in this process can be divided further recursively. Find the maximum sum that can be obtained by summing up the divided parts together. Okay, so let us try to understand the problem statement with the help of an example. So let us take the example. So in order to understand the problem statement better, let us take an example where n is equals to 24. And let us go ahead and divide n recursively. Okay. So let us divide n recursively into three parts. So n can be divided into three parts, which is n by 2. So n by 2 is 12. N by 3. N by 3 is 8. And n by 4, which is 6. Okay. Now let's go ahead and divide 12 into three parts. So 12 can be divided into three parts, which is what? N by 2, which is equals to 6, n by 3, which is equals to 4, and n by 4, which is equals to 3. Similarly, 8 can be divided into three parts. Let's go ahead and do it. 4, 2, and 2. 6 again can be divided into three parts. So let's divide it. So this is equals to how much? 3, 2 and 1. Now 6 again can be divided into three parts. So 6, let's divide it. So this is 3, 2 and 1. Similarly, 4 can be divided into three parts. So let's divide 4 into three parts. So this is equals to 2, 1 and 1. Similarly, let's divide 3 into three parts. So this is 1, 1 and 0. Let's go ahead and divide 4 into three parts. So similarly, let's not go ahead and do all the combination, but this should be more than sufficient to explain the concept here. So, but similarly, we can go ahead and divide all these things, okay, till this becomes 1 or 0. Once it becomes 1 or 0, it cannot be further divided, and in which case we are going to go ahead and return that number itself. Okay, so for instance, so now let's move from backward. So let us say here the number is 0. So this is something which we are going to call it, okay, 0 itself. Here the number is 1, so this is 1 itself. Similarly here, now 3, when we have divided into three parts, we got the sum. So let us add these sums over here. So this is equals to 1 plus 1 plus 0. So this becomes equals to 2. Now 2 is less than or equals to 3. So what we are going to go ahead and use is 3 itself rather than using 2. See, 3, when we decompose 3 into three parts and take the sum of those three numbers, then it is equals to 2. And since we have to maximize the sum, or as per the question, if the sum is less than or equals to the number itself, then we are going to use the number itself. Okay, so in this case we are going to use 3 itself. Similarly for 4, if you see here, so 4 is equals to 2 plus 1 plus 1, which is equals to 4 itself. So 4, since the number is equal here, so we are going to use this number itself. All right. Similarly here in this particular case, this is 3 plus 2 plus 1, which is equals to 6. And now since 6 is less than or equals to 6, so we are going to use 6 itself. Now when we come to 12, we will be able to decompose 12 into these three parts, and hence the sum of this will be 6 plus 4 plus 3, which is equals to 13. So rather than using 12, we are going to go ahead and use 13 since the sum is greater here. So we are going to use 13 rather than 12. Okay. In this particular case, this is 4, 2 and 2. So if we add this 4, 2 and 2, this will becomes equals to 8. So here we are going to go ahead and use 8 itself. Okay. Here, if you see, this is equals to 3 plus 2 plus 1, which is equals to 6. So in this case also, we are going to go ahead and use 6. Okay. Now let's take for 24, let us compute it. Well, 24 will be equals to 13 plus 8 plus 6. Please note here I am using 13 rather than 12 because 13 was the highest number. So in this case, the sum will be how much? Well, this will be equals to 27. Okay, so for this particular case, our answer will be 27. Folks, now let us see how we will be able to use dynamic programming in order to solve this problem. Okay, so one thing which is evident from here is a number which we have decomposed one. So for instance, here if you see, we have decomposed 6 over here, then again we are going ahead and we are decomposing 6. So either we decompose 6 over here or we decompose 6 over here, the resultant will always be the same. So this becomes a sub problem whose solution we can store in a table, and as and when we see this sub problem again in future, rather than solving that sub problem, I will go ahead and use the DP table in order to get the appropriate value. So that is one concept which we understand from here, or the one optimization which we understand is that we will have a DP table where we will be storing the answer to the resultant sub problem, and if in future if we saw the same problem again, then rather than solving that sub problem, we will go ahead and use the DP table. Okay, so that's the concept, folks. Now let us see how we will be able to code it out. So let me just go over your pseudo code. So what we are going to do is that we will be having a DP table, and initially all the elements of the DP table will set it to -1, which simply denotes that we have not solved this subproblem yet. And the size of this DP table will be equals to number itself, so n plus 1. Okay. Now, once we have this, now let us look at the pseudo code. So let us say we want to have our max sum. So in max sum, we want to get for number n, and this is our DP table. So if this n is equals to 0 or n is equals to 1, then further decomposition of this number is not possible, and in which case I am going to go ahead and return the number itself. All right. If this is a sub problem which we have already solved, so I'm trying to solve it for n, and let us say if this sub problem we have already solved, so if this is already solved, then this value will not be equals to -1, in which case I am going to go ahead and return dp of n. Now let us say this is a sub problem which we have not solved so far. So we are going to go ahead and solve this sub problem, and we are going to put the value in dp of n, and that will be equals to maximum of the number itself, right? So if you see this, so what we are doing, either the number itself, so either the number itself or the sum of the values over here, right? So that is what we are going to go ahead and write it over here also. So either the number itself or max sum of n by 2 comma dp table, and remember this will be our int, okay, plus max sum of n by 3 and our dp table, plus max sum of n by 4 and our dp table. Okay, and that is how we are going to do it, and towards the end we are going to return our dp of n. So that's the pseudo code for this problem, folks. So now let us look at how we will be able to code it. So the code is pretty much the same. So we have a dp table, and then we are returning max sum n and dp table. And if so, in this function, if it is a number which cannot be decomposed further, then we are returning the number itself. If this is a sub problem which we have already solved, then dp of n we will return it. Otherwise, we are going to go ahead and update dp of n and return dp of n. So that's the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. So that is all from this video, folks. In case if you have any comment or question regarding this video, please feel free to use the comment section and I will try to address them. Thank you.